Okay, here we go. Let's go. 1.4. I want to get through 4 templates like the other hour is. So. Okay, adding, subtracting, multiplying, dividing fractions today. So, for the first part, it's just your basic one with numbers, and then we'll do the same concept using expressions. If I gave you 1/3 plus 1/2, that's a no-brainer that the common denominator was 6, right? But the bigger you go, the harder the problem is because you have to find the common denominator, correct? So here are the steps on how to find the common denominator when they're not like 3 and 2. The first thing you do, I did put steps with the 3 there. Steps. Step number 1, prime factorization. You prime factor. So 63 and 42, the first step when you're trying to find the common denominator is to prime factor. So 63 is made up of 7 and 9, right? 7, 3, 3. We can go a little bit faster, not keep making the tree bigger. We can do all that all at once, right? And 42 is made up of 6 and 7, which most of you know is 2 times 3 times 7. That's the first step. And if you understand this, then we're going to do the exact same steps when you're given variables, correct? So now, step number 2, you compare them and you take the greatest of all the prime numbers. You take the greatest of all the prime numbers, which is called the, I think you guys know the LCD stands for least common denominator, right? So let's find the LCD over here. Okay, this is how we find the LCD. We have a group here that we prime factor down, and we have a group here that's prime factor down, right? And you take the greatest of every prime number, comparing them. No 2s, 1, 2. Which one's bigger? No 2s, 1, 2. 1, 2. Now we do the next prime number. 3. 1, 3, 2 3s. Which one's bigger? 2 3s. 1 7, 1 7. 1 7, right? Which makes 2 times 3 times 3 times 7. To make this go a little faster, you plug that into your calculator and you get 126. What is that called? The least common denominator. You did that up there, you just didn't know you were doing it, right? This is already prime factor, this is already prime factor. 1 2, no 2. Would you have taken the 2? 1 3, no 3. Would you have taken the 3? What's the least common denominator? 6. You just didn't do that because the numbers were so easy back in the day, right? So, okay, now, step number 3 and step number 4, rewrite the denominator, and also then you need to also rewrite the numerator. So it's not that hard to add and subtract fractions if you know the 4 steps. Prime factor, greatest prime, or LCD, rewrite the denominator, rewrite the numerator. So, keep on going with this. We found out that the LCD is 126. You're going to rewrite the denominators now so that they're the same. They're the same, right? And now you have to rewrite the numerators, right? Well, 63 times something gives you 126, and I think most of you see that. You would double it to get to that, right? So if you're doubling that, aren't you doubling that? Which gives you 8. 42 times 3 is 126. You could just play around with it or take this divided by that and come up with 3 yourself, right, on your calculator. But we don't have time to do that today. So if you multiply 42 times 3 to get to 126, don't you also have to multiply 5 by 3, which gives us 15? And now can you add them together now that they have a common denominator? 8 126 plus 15 126s, 23 126s, right? Final answer. Final answer. Try to average about 5 minutes. Play 5 6 minutes. I think that's it on that one, right? Now it's going to become a little tougher because that was numbers. I don't even know what grade you learned that at, but now we're just going to learn how to, do you see that there is no adding and subtracting really? It's just one huge fraction, right? And when you got a whole bunch of variables, the name of the game starts with the letter F. And you have a whole bunch of factoring, right? So you have to be good at factoring. This one is 4 problems from yesterday in one because you've got a numerator, a denominator, and a denominator that needs what done? Factoring, right? So you have to be very good at factoring in this class, right? So right before Thanksgiving was factoring probably the main chapter in Algebra 2, factoring, because you definitely need to know how to factor. So, okay, this one, it's just a division bar, so all you're going to do is factor and look for things. The people that, remember some people were cancel happy last year, I called them cancel happy. They just took the shortcut and saw that there was an r to the second here and an r to the fourth, and they just started canceling out. But you can't cancel out because you have to factor first, right? You have to factor first. So let's do the bottom first. What's the greatest common factor between those two terms? R to the third. And what do we have left? R plus 2. I would pick the easier one first. The top one, there's a lot of things wrong with the top one. The top one is a trinomial, correct? The top one doesn't have a greatest common factor like the bottom one. Everybody see that it doesn't have a greatest common factor? And there's something else that's major wrong with the top one. It's in the wrong order, right? Isn't it supposed to be the highest, then the middle, then the number at the end? So I'm going to rewrite it. Doesn't it really go a negative r squared, then the positive 3r, then the positive 10? It's supposed to be in decreasing order, so that's what's wrong with it. Okay, start again. It doesn't have a greatest common factor, so you just start factoring it. And when you factor and you don't want to use the crisscross method and the box method, all you do is experiment to come up with the right answer, right? Experiment's going to work. You just got to play around with it. If it's a negative r to the second, you only have one choice. It can only be a negative r and a positive r. There's no choice on that, right? You don't even have a choice on that. A negative r and a positive r. You have 2 sets of factors of 10. I'm going to try to show you a shortcut. The other hour couldn't figure out my shortcut. There are 2 sets of factors of 10, 1 and 10 and 2 and 5. But why don't you even have to try the 1 and the 10? Why don't you even have to try the 1 and the 10? Because, no, it has to cancel out something in the bottom that has an r plus 2 to it. And a 1 and a 10 doesn't have a 2 and doesn't have a 2 in it. So why even try the 1 and the 10, right? It has to be the 2 and the 5, correct? It has to be. That's supposed to be a shortcut to help you come up with the factors there because you have to look in the denominator to decide. That other hour could understand that, but I don't know if it's supposed to be this way. I guessed. I got lucky. I didn't know if this was supposed to be plus 2 and plus 5. Or plus 5 and plus 2, and I put it in the right spot. Do you always get lucky and put it in the right spot the first time? No. Let's check it. 5r, take away 2r. Does that give you a positive 3r in the middle? Do we get it the first time? Yeah, we don't always get it the first. Sometimes you have to rearrange it. And look what happens to the r plus 2's finally cancel each other out. And you're left with your final answer. Might as well rewrite it. Negative r plus 5 over r to the third. Final answer. Okay, you got to be really good at factoring down here. The good thing about this one is it's not an addition sign or a subtraction sign. It's a multiplication sign. And whenever you're doing multiplication or division, you don't have to find a common denominator, right? But you can't be cancel happy. You can't just cancel out this 6 and this 6, because this is in the numerator and this is in the denominator, because these are all expressions, so you have to, what? Factor. So, start with the top one, my favorite one, 4x squared minus 9. Is there a GCF? No, are you guys good at 4x squared minus 9? Yeah, that is 2x minus 3 and 2x plus 3. Done with that one. This one down here doesn't have a GCF. It doesn't have a GCF, and you really only have one choice for the 2x squared. What's the only choice for the 2x squared? 2x and 1x? Doesn't matter which way you write it. What do you guys want to do? I don't care. 2x first, then 1x. Factors of 6 are 1 and 6 and 3 and 2. Probably work with the 3 and the 2, right? I'll just put the 3 here. I didn't even mean to do that. I was trying to not make it work, and I made it work without. I was going to try to not make it work, but 4 plus 3 gives us the 7. I want to show sometimes it doesn't work. And you have to rearrange it. I should have put the 2 there and the 3 there, and it wouldn't have worked, right? So, okay, now times. Trinomial looks really complicated. If you looked at that, if somebody in this room doesn't know what to do, what would you tell them? GCF. It makes a huge difference when you take out the greatest common factor, which is x squared, which gives you 4x squared plus 6x plus 9. I have already proved that one. X squared, 4x squared plus 6x plus 9. You're not done though, because you have to see if you can factor that trinomial in there, right? You keep going until you can't go anymore. I'm going to go up here and make an arrow, and I'm going to do 2 sets of parentheses, and I'm just going to experiment up here. Factors of 4 can be 1 and 4 or 2 and 2. I'm going to start with the 2x and the 2x. And factors of 9, I'm going to start with the 3 and the 3. And I'm going to put them in there, and I'm going to check it to see if that makes sense. 6x and 6x gives us 12x, and I need a 6x, so that doesn't work. So then I don't like my 3's. I know there are other factors of 9 and 1, right? That just makes it even bigger, doesn't it? 18 and 2, that doesn't work. What happens if I switch it from 2 to 2 and I switch it to 4 to 1? That doesn't work. So you don't need to, at least you tried, it doesn't work, so don't you have to leave it by just taking out the GCF? At least you got that, right? At least you got to there, right? And I tried, nothing works. Nothing works. So we understand that I tried and nothing works. All over. Oh, this one looks really crazy, right? Look at that one. Doesn't that look foreign? But what's the first thing you say? GCF, and it makes it way easier once you take out the GCF, and the GCF is x to the 4th, parentheses, 8x to the 3rd minus 27. And I know 2 people in this room that know the difference of 2 perfect cubes really well, because they studied it Sunday night, and they know the formula down really well, right? So, here we go. Perfect cubes. A lot of you guys are good at perfect cubes, not just those 2. But ready to do the perfect cube? Here we go. I'm going to rewrite all of this and then cancel that out because I made it a new one, right? Because some of you need practice on it. X to the 4th. Little parenthesis, but it doesn't mean really little that you can't even fit everything in there, right? You need little parenthesis and big parenthesis. If this is a minus, then this is a plus or a minus? Minus. If that's a minus, then this is a plus, and this is automatically 100% plus. We're going to use one of each of them goes here. Some of you are ahead of the game and already putting it in there, right? One of them is a 2x. One of them is a, you already used one of them, you have to use 2 of them here and 2 of them here, right? 2 of them makes 4x squared, and 2 of these little guys make 9. And then to get the middle part, you multiply these two together to give you 6x. And now I just redid that, so I have to cancel that out. Now that everything is factored, anything is game in the numerator with anything in the denominator, right? You're looking for the same things in the numerator as there's the same thing in the denominators. These two are the same. The 2x plus 3 is in the numerator, and the 2x plus 3 is in the denominator, so you can cancel them out. Isn't that interesting? That this huge thing that we tried to factor is also where? In the denominator. See how they make these problems be like nice and perfect, and they make it, you know how it all comes down together. It's hard to make up math problems so that I would want to make this problem up so that you can start canceling out, right? That'd be kind of hard to do that. So what else can we cancel out? That's it? Yep, 2x minus 3. That's it? Yep, these two. And then we're pretty much done, right? We have nothing left. Well, we have nothing left on the top, do we? Nothing except the number 1 over x squared x plus 2. Final answer. Okay, let's see what happens. Let's see how much we get done. We're going to try to get through 2 more templates. Hopefully we can. Okay. Now we're going into adding and subtracting fractions, but now they didn't turn it. Now they're turning into expressions and not just numbers, right? Why is this one so easy, number 4? They already have a common denominator. It's not easy if they have a common denominator. So you don't have to prime factor down and find the least common denominator because it's already there. What's the common denominator? X squared minus 9. Can't you put the top up there all under what? 15 minus 5x? Do you wish it was that easy? Of course it's not easy because you still have to factor. Anytime you're dealing with expressions, you have to factor. Bottom one's really easy, right? You guys are really good at x squared minus 9. Probably ahead of the game, already doing it, right? You guys done with it? The x squared minus 9? X minus 3, x plus 3? Huh? What's the greatest common factor? 5. What happens when you take a 5 out? 3 minus x. Boy, there's some that look almost identical, but they're not. They're not identical. These two that I'm circling are not identical. They are opposites. No, not reciprocal. Do you know what a reciprocal is, you guys? 3, yeah, flip it. That's a reciprocal. This is the what? What is that? What are these two called? What are these two called? Opposites. Are these opposites? What happens when you cancel out opposites? What's 5 divided by negative 5? What happens when you divide out opposites? Don't you get a negative 1? So what happens when you divide out opposites? What do you get? Negative 1. Put the negative somewhere. Where do you want to put the negative? Some books put it way out here. Have you seen them way out here? Some books put it here. Some books put it down there. Whatever floats your boat, right? Where do you want to put it? You know how some books put it way out in front? I like putting it in the numerator. So I'm putting it in the numerator. Final answer. Final answer. Whenever you cancel out opposites, how do we know that? All the way back to what grade? I don't even know what grade. I have no idea what grade. It makes negative 1. Makes sense, doesn't it? Okay, let's do this one. We got 10 minutes. We should be able to finish. Okay, what's wrong with this one? You're adding and subtracting fractions, but what's wrong with these 3? They don't have the same common denominator. So, here we go with our steps. What's our steps? What's the first step? Prime factorization. Is it the same concept with this? This one's done. This one's done. But this one can get down to, yep, t minus 3, t plus 3. Exactly the same concept. Now you can see how things expand the farther you go into math, right? You can do it with numbers, you can do it with variables. After you prime factor, You take the greatest of every factor, right, of every prime number, which is called the LCD. You guys ready to go? 1t plus 3, no t plus 3, 1t plus 3. Which is the biggest? 1t plus 3. I'm going to put them in parentheses. No t minus 3, 1t minus 3, 1t minus 3. Which one's the biggest? 1t minus 3. So what's the common denominator? T plus 3, t minus 3. Do you know what steps 3 and 4 are? 3 is to rewrite it with their new LCDs. Nice and t plus 3, t minus 3. I'm going to go as fast as I can with this. Getting them all down, feeding them back and over again. Okay. And this is what we did on the front page, basically, right? Same thing. You compare the old denominator and the new one, and do you see the difference between the two? They're missing the, what are they missing? T minus 3. So can we do this in our head? Isn't it going to give us t squared minus 3t? T squared minus 3t. This little guy is missing, what is this one missing? T plus 3, which gives us 4t squared plus 12t. I think I did that right. And this little guy is missing nothing. It's identical on the bottom. Do you see that they're identical? So if they're identical, do you have to switch the 18 to anything? No. So can we put them all over one common denominator? T plus 3, t minus 3. T plus 3, t minus 3. And then you can put all the numerators together. So how many t squares do we have? 5t squares plus 9t minus 18. 5t squared plus the 9t minus 18 all over t plus 3t minus 3. Are we done? No, because you always have to look to see if you can factor the top. And what's a shortcut to help you factoring, to help you get the right answer? Well, the 5t squared, there's nothing you can do with 5t squared. Doesn't it have to be 5t and 1t? Yeah, there's no choice. Now, look in the denominator to help you factor, right? Doesn't the denominator help you factor? This one has to be a plus 3 or a minus 3 in order to cancel out, right? It has to be a plus 3 or a minus 3. See how that helps you? Which one? Should we try? Which one? I don't care. Oh yeah, but is it minus or plus? Which one do you want? The plus 3 or the minus 3? Minus 3. So this one's going to be plus 6. And guess what? We did it wrong, but that's good that we did it wrong. Isn't this a negative 15 t's? And isn't this a positive 6t? What's a negative 15 and a positive 6? Negative 9. So that this one must be the plus, and this must be the, is that okay that we have to switch it? It's okay, but the good thing is there's still a t plus 3 down there to cancel out? Yeah. I'm not going to rewrite it, but the final answer is 5t minus 6 and t minus 3. Final answer. I'm not going to rewrite it. Last problem, and then we will end up the last template tomorrow. Last problem. It should only take about 4 or 5 minutes. So when we're done with this, you guys can walk out the door. What happens when you have a fraction plus a fraction divided by a fraction minus a fraction? It's called a complex fraction. But they're really not even that hard if you just ignore and just work with this one first. So just work with that one. What's the common denominator in the numerator? SR. Everybody understand that it's SR? Right? So can we rewrite them with SRs? SR, SR. SR plus SR. Okay, ready to look at the old denominator? Where's the old denominator? Isn't it right here? Isn't this the new one? What's the difference between these two? R. So what does that make? Yep. What is this one missing? X, so isn't that x squared? Okay? And then we're going to just make the bar, and we're going to leave that top below now. We're done with the top. Can we do the same thing with the bottom? I'm going to circle the whole bottom and say to myself, well, what's the common denominator for these two? What's the common denominator? R squared, S squared is the same concept down below, right? Same concept. Complex numbers aren't even that hard. You have to go slow and you have to be organized, right? Go slow and be organized. Isn't this one missing an r to the second? So isn't this going to be r to the fourth? And isn't this one missing s to the second? So isn't this going to be s to the fourth? So the first thing you do is find common denominators in the numerator and find common denominators in the denominator. And now comes our last spot. You're going to rewrite these together with what? One common denominator. So how would you rewrite that? R squared plus s squared all over what? SR divided by r to the fourth minus s to the fourth all over what? R squared, s squared. So we just went through all those fractions and we simplified the numerator and we simplified the denominator. So far, so good? But how do you do a fraction divided by a fraction? You change this division sign to multiplication. So ready to do all that? So we're going to rewrite this and rewrite. So we're going to r to the second plus s to the second divided by SR. So did I do anything but just rewrite it? I just rewrote it. I'm just going to change the division sign to multiplication. And what do you have to do with the second fraction if you change this from a division sign to a multiplication? Flip it to the reciprocal, r squared, s squared over r to the fourth minus s to the fourth. And we got a minute to go. Since this is multiplication, you can look to see what they have in common and just start canceling out. But before you can cancel out, you have to look to see if you can factor this. Can you factor this with the plus sign in between? Nope. How about this guy? It's my favorite one. Isn't this my favorite one? My favorite one is a difference of what? Two perfect squares. We're going to finish this. R to the what? Second minus s to the second, and r to the second plus s to the second. That's all I can do. That's the only one. We have to do all four of them in that one problem. Is that bad to just do one of them, of the four? That's not bad. We got a minute. Can't this guy and this guy go away then, since they're both r to the second plus s to the second? Is that it? Nope, the s and the r. Goodbye to this s. So make this one s. Goodbye to this r. Make this one r. Now we are done. Don't be cancel happy and cancel out the r squared and the r. It's connected with the minus sign. So I know I didn't finish notes, but tomorrow we'll finish the last template. I should finish this. Isn't the final answer rs over r squared minus s squared? Yep.